This is the screencast for section 1.4, example 3. We're going to find the domain of a composition function. The domain of a composition function is not as easy as just adding or subtracting or multiplying or even dividing two functions. A number has to get plugged into the inside function, which then becomes its range, which then becomes the outside function's domain. And it's this whole big obstacle course that every number has to go through. So let's look at an example. Here's the composition g of f of x. So the inside function here, when I plug in a number, that number has to be first in the domain of f. The first function it reaches is the f function. Well, the domain of the f function is all real numbers because I can square anything and then subtract 1. So the domain is so far all real numbers. The f function doesn't give us any restrictions for what we can plug in. The restrictions, the tricky part, comes between what comes out of that f function that can't get plugged in to the square root part. So we need to look at the range of the f function. I graphed the f function on my calculator, and I can see that the range of the f function is -1 to infinity. Again, the conflicts arise when there's something that can come out of the f function that can't get plugged into the g function. So in other words, the g function's domain, the square root of x, is 0 to infinity. There's a problem. I will have numbers coming out of the f function that are negative, and I can't plug in negatives to the g function. So the problem is anywhere between -1 and 0 for the range of f. So I'm going to look at the f function, and I can see here's where the range is negative. These are the y values I can't plug in to the g function. I can't take the square root of those. The domain values in the f function that cause those are from -1 to +1. So there's my restriction. I have to cancel out anything between -1 and +1. So the domain is no longer -infinity to infinity. There's actually some numbers that I can technically plug into f, but their outputs won't be able to plug into g. And those are between -1 and 1 because they create negative values that we can't take the square root of. So the domain of the g function is -infinity to -1, and we can include -1 because 0 is an okay number to take the square root of. -1 squared minus 1 is 0, square root of 0 is 0. And then +1 to infinity. Now looking at the composition function f of g of x, the first function that an input is going to have to tackle in this obstacle course is the square root of x, or the g function. Well, I can't take the square root of negatives, so the domain of the g function is 0 to infinity. So already I've got some serious restrictions in our domain. I can only plug in so far anything between 0 and infinity. Now if anything of those that I plug in create outputs that I can't plug into the f function, then I'll have a problem. So let's look at the range of the g function. The range of the g function is 0 to infinity. So I need to see which of those outputs can I not plug into the f function. Well, the domain of the f function is all real numbers. So there are no conflicts between what's outputting from g and what's inputting for f. I can only plug in 0 to infinity, and all of those are okay with the domain of f. So there aren't any further restrictions to our initial 0 to infinity domain of the first function those values have to tackle, the g function. So the domain of f of g of x is 0 to infinity. The now try problem for example 3 is number 17. I've created the composition function f of g of x. The first function that any input is going to have to tackle is the inside function g of x. G of x's domain, let's see, I can't take the square root of negatives, so the domain is going to be including -1 to infinity. So already my composition function as a whole can only plug in -1 to infinity. I can't plug in all real numbers just because of that square root. Now we have to see if any of the range values of that g function won't be able to get plugged in to the f function. The range of my g function is 0 all the way up to positive infinity, and the domain of my f function, which is just a parabola, is all real numbers. So there's nothing that the g function will output that I can't plug in to the f function. So there are no further restrictions on the domain of g. So the domain of the composition is just the same as the domain of g. -1 to infinity, including -1. G of f of x, the composition means that f is the input, f is the first function any input value is going to have to tackle. The domain of that parabola is all real numbers. The output, or the range of the f function, is -2 to infinity. So far, the domain of f doesn't give us any restrictions to what we can plug into the composition. However, there are some range values that we cannot plug into the g function. The domain of the g function by itself, the square root of x plus 1, is -1 to infinity. So I have some problems between -1 and -2. Any range value that comes out of the f function between -1 and -2 is going to cause a problem in the composition. Any x value between -1 and +1 causes a range value between -1 and -2, which cannot get plugged in to the g function because we can't take square roots of negatives. Therefore, I have to leave out of the original domain anything between -1 and +1. So the domain of the composition becomes -infinity to -1, and then +1 to infinity.